Example 3. Let A equal to -1, 2. This time we're working in 2 space. And we'll let B equal to 2 and 6. Okay. Ah! Wow, now these crazy lines are coming up all over the place. Okay. A line passing through A in the direction of B is, parametrically, oops. Okay, now that we're getting to the bottom of the page, these lines are going to actually show up. So you know what I'm going to do? I'm going to actually skip and jump over one. So we have x of t is equal to a plus t times b, which is going to equal a, which is -1, 2, plus t times 2 and 6. So let me write this in component form. The vector x is just a vector, so it is some point xy is equal to -1 plus 2t, -1 plus 2t, 2 plus 6t, 2 plus 6t. There you go. So now I have the component version of this. Well, now let me separate these. X is equal to -1 plus 2t. X is equal to -1 plus 2t. Y, let me do this. Y is equal to 2 plus 6t. Let me solve for t. This is x plus 1 divided by 2 equals the parameter t. This is y minus 2 over 6 equals the parameter t. And the t's are equal to each other, right? It's one parameter. This is the power of it. It's one parameter. So let me set these equal to each other. X plus 1 over 2 equals y minus 2 over 6. Let me cross multiply. I get 6x plus 6 equals 2y minus 4. Let me bring the y over. I get 6 minus 2y equals -10. Look at that. I've taken my parametric equation, and now I've recovered the standard form of the equation that you're used to ever since middle school and high school, an expression of the line in terms of the two variables x and y. We can do this in 2 space because we have just the 2 coordinates, 2 equations that we can set equal to each other. The problem is when we try a parametric representation in, let's say, 3 space, we can't solve for t and set these things equal to each other and come up with some equation like this. So now that we're actually moving into higher dimensions, excuse me, the parametric representation of a line is the only representation of a line. It is the best. So this whole idea of working with x's and y's that we've been doing all these years, it's good and it was fine for what we did, but now we need to move on to a more powerful tool. We need to move on to parametric representations of lines. The parametric representation of a line is valid in any number of dimensions. I no longer need to work with x and y, so we're moving up. We're becoming more sophisticated with our tools, and that's why we introduced this notion of a parametric equation. Okay. That's it. So again, if we need to recover it for dimension 2, that's fine. I mean, this is certainly doable. Again, you solve for t, and you do this. But we're going to be working strictly with parametric equations because it is a more powerful tool and it works in any number of dimensions. In fact, the parametric representation, again, is the only representation that works in dimensions greater than 2. Okay. Thank you for joining us here at Educator.com. We'll continue our discussion of parametric lines and planes next time. Bye-bye.